Can show you the diversity of the audience. Okay, so yeah, Leo is on, so let's start. I'll screen share here for everybody. Okay. Spoiler. Let's present. I will first make sure you all know at least the basics, or at least have seen the basics of Python, because if I jump straight to classes, I may lose some of you. So I will start from the real basics, but it won't take much time. Okay, so basically programming is giving commands in sequence. So if you mess up the sequence, you will mess up the code. That's fundamental. It's not like asking your brother to go buy milk and put the shoes on. He will not first go buy the milk and later put the shoes on. So he'll do the inverse because he can't understand what you mean. So in a code, the interpreter doesn't understand what you mean. So you have to say precisely first, put the shoes on, then go buy the milk. In Python, you have to know at least the most basic commands, and the commands, the famous ones, the most used. So I will give you some examples. For example, in this piece of code here, I'm showing you. Can you guess what's going to happen? So I have this code first. A is a variable, equals input. This is a command. Do you know what input does? You can mute.
It'll ask a question in the command line.
Perfect. The string I inserted here in the argument of this function pops up in the console. And then you can type something, and whatever you type in the console will be assigned to the variable A. So that's the question that Dan is talking about. So you insert the answer in the console, and it now belongs to the variable A. The print, what the print does. What exactly? So line 9, what does line 9 do exactly?
It prints what is inside of it.
Yes. Inside the quotes. And
Yeah.
what happens with these brackets A?
So it will convert it to the A as a variable instead of printing A directly.
Exactly. 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 So if you type, for example, 5 in the console and press enter, now A is 5. The value of A is 5. But when you print, you inserted A, and A is inside brackets. When this F modifier here, which means format, it parses the value of A into the string instead of the letter A, okay? So if you type, I don't know, 130 in the value of A, it will print you inserted 130. And what does line 10 does? A equals float A. What is this?
It just changes A from, like, if you just put in 10 or something, it'd probably be an integer, changes it to a float so it'll have decimal points.
And even if I type, for example, 1.0, if I type 1.0, the A will not be a float. A will be a string because you type it in the console. By default, it's a string. So even if I type 1 point something,
yes,
I have to convert to float anyways.
Yep.
Right?
That makes sense.
So,
Yeah.
Now that a is a float, I can start doing math operations. So let's say a is 5. I typed 5, pressed enter, and now I do a equals a times a plus a. And then I print. The output is a. What is the output?
30.
30? Okay, that's it, 30. See if you guys could understand what's going on. See if you guys can agree that the printed string will be, the output is 30.
I I agree with that. That seems correct to me.
So this is very strange, right? So when I was like the first time studying programming, I saw things like this. I automatically started thinking, okay, a times a is 0, because you pass the a to the other side, or you subtract a in the two sides, and then a equals 0. No, it's not a mathematical expression. It's a mathematical operation in the right side, and it's being parsed, assigned again to the variable a. So if a is 5, you first do the operation. So 5 times 5, 25, plus a, 30. And now you assign to the variable a. So a now is 30. Okay. So here's everything it's being done. So it's written in the slide. If you need the slide, you can ask me, and then it will be everything here. Okay, what about this one? What is the output of this code? Who is not familiar with the syntax in this code? Can you guess what result it will be?
It just prints all the even numbers. And then if it's not even, it prints the number is odd or the counter is odd.
Perfect. Yeah, that's it. So for those who are not familiar with the syntax, for I in range 5, so first, this for some variable in a set of variables. The for loops I among the values of the set of variables you are providing here. So range 5 means 0, 1, 2, 3, and 4. They are 5 values, but starts from 0, 0, 1, 2, 3, 4. All right? And I, the variable I, loops over these 5 values. So first I becomes 0. It starts at 0, then becomes 1, becomes 2, becomes 3, becomes 4. And that's it. The loop ends, right? But every time you loop, you do what is inside the loop, the operations inside the loop. So for example, the first operation is a test, the if statement. If not, I, and then percentage 2. What is this? What is I percentage 2? Is the remainder of I divided by 2. So if I, for example, is 4, 4 divided by 2 is 2, remainder 0, right? No rest. So 4 percentage 2 is 0. Now, if I is 3, for example, 3 per 2, 3 divided by 2 is 1, remainder 1. So 3 is not an even number. So only even numbers will return 0 in this operation, and all the odd numbers will return 1 in this operation. All right? The operation not, converts everything that is 0 to 1. And 0 means false, while 1 means true. So if your number is even, the remainder is 0, but the not converts it to 1. Now it is true. If it's true, you do what is inside the if statement. So in short, if your number I is even, you print I. That's all. If it's odd, which is else, so else is basically testing whether the previous statement is false. So if the number is odd, you print the counter is odd. So I could, that's not a huge problem. But I could like do the example and run. If you want me to do it, go ahead and ask for it. Okay, so this is everything it's being done. Range 5 is a list, so 0, 1, 2, 3, 5, and I loops among all the values. The percentage is the remainder, the quotient remainder. Not converts 0 to 1. And if it's any value other than 1, converts to 0, right? If the test is satisfied, print I. Otherwise, print the counter is odd. Now let's start the real content of this class. Python functions. So can you guess what the output of this code is?
30 again.
30 again. See if you guys can agree on that.
Yes.
Leo, agree? What about you, Leon?
That seems correct to me.
So basically here what's happening, instead of defining the operation and assigning the result to the variable A like we were doing before, here we are defining an operation. Inside the operation, we put whatever mass we want to do, and then we just call the operation. So this is more organized way of doing several like messy calculations over and over and over again, instead of having to type everything, instead of Ctrl+C, Ctrl+V every time. You also organize your functions, and when they are organized, you can distribute the functions to other people. So I define my page row operation here, and then I copy and send to Danny, and Danny can implement it in his code without any conflict. Because if I send to Danny A equals A times A plus A, maybe in Danny's code, A is already defined somewhere else. So it will generate a conflict. So more work to Danny to solve. But when I write in a function, I guarantee there will be no conflict when I distribute my code to other people. And I guarantee that my code is organized and my functions are not entering conflict with other stuff. And stuff in my own code. For example, here I already defined A equals 5, right? So when I do this operation inside the function A equals A times A plus A, this A inside page row operation has nothing to do with the A outside. They do not talk to each other. The variable update only happens when I call the function and reassign to the value to the variable A. So even though it's the same name, the same variable name, A inside the function does not affect the A outside of it. So you do not have conflict because you're using a function. So let's say you are doing like a very mathy software, and all your functions are x squared plus, I don't know, cosine of x, x, all over the place. And imagine if they talk to each other. So in a function you do x equals x squared, the other function you do x cosine of x, and they one function updates the x on the other function, it's a mess. All right. So it's much more organized, much more concise, many advantages. All right. That's everything of functions you need to know. Now, other content. Data manipulation. Regardless of whatever you're going to do in your project, data manipulation is core for any programming language. So if it doesn't mean you will work with data analysis, doesn't mean. You could, for example, be working with development. You will have to manipulate data eventually. So effective ways of manipulating data in Python. The most basic one we saw, variables. You can store a string, an integer, a float. So here I'm giving the three examples that I'm saying here. A string, so you define with the quotes and you put whatever you want inside of here. Integers like 1, 0, -1, and floats. A float could be, I don't know, cosine of 2, could be pi, could be logarithm of something, I don't know. Then you have lists. So in a list, you can store a wide variety of variables. So in this case here, A could be 1, could be 2, but in a string format, could be a word, hello, or could be another list. Everything inside the same object called list. All right. You also could use matrices. So matrices are basically a set of lists. That's basically what a matrix is. And also dictionaries. So dictionaries do basically what a list does, but you provide keywords for each of every content inside the dictionary. So let me give you an example. Let me get rid of this. So A equals 1, 2, and hello. By the way, it doesn't matter if you use like a single quote or double quote. It doesn't matter. Okay. Now I'll print A. If I print A, where is it? Okay. If I print the variable A, I get exactly what the list is. 1, the string 2, and the string hello. All right. But let's say I want to print only the first entry, the first element of the list A. I can do this, print A, and then I access the first element. Oh, I'm sorry, this is not the first element. This is the first element, right? Because counting starts at 0. So this is the first element. When I run this, I'll get first the list, the entire list, because I'm printing the A, and now the first entry of the list, 1, right here, right? Now let's say I know that my list has the word hello, and I want to print the word hello. I have to remember the position of this word in the list. I have to remember that hello is in the third position. So I type 2 here and run. And hello is printed in the console. But this is not the most like reliable way, because I have to remember where each of the entries are, right? But if I use a dictionary, so I will now define B as a dictionary. So my word, the word I want is hello. And I have other stuff here, like 1 means 2, 2 means other stuff. Now I don't need to remember the position of the word hello. I just refer at hello because I know it's associated with the string word. So now if I print B word, I will get hello out of it. If I print, for example, 1, oh, by coincidence, it will print exactly the second variable. But even if it's the first one, look, I am accessing. So if it was a list, I would be accessing the second variable, which is hello. But dictionaries work by keywords. So if I provided the keyword 1, it will search the keyword 1 in the dictionary, which is this one, and will return me the associated variable, which is 2. So if I print this, it will get me 2. Right? So this is much more interesting. For example, if you are developing a game, which we are going to. So we have, for example, a zombie, and I will define the zombie as a list. So the zombie has a life of 100. It carries a weapon, which is hands, and it has a speed, which is, I don't know, 10. And you could go ahead and put strength, agility, intelligence, everything. All right. What is the error here? Undefined name hands. Oh, of course, this must be. So now I'm running the game, and I want to access, for example, well, this zombie in particular, what weapon is he using? So I can print zombie weapon, and now I know it's hands. All right. If I print life, now I know it's 100. Now let's say I want the zombie to take damage. Now I do zombie life minus equal 5. And now I can print again. So this is basically the zombie taking damage from something. So before taking damage, it was 100. Now it's 95. Right? But there are a few problems here in the purpose of a game. So the first problem is, if I want a second zombie, what if I want a second zombie? I have to redefine the entire thing. Zombie 2 equals I have to redefine the entire thing. This is awful. And what if the damage of the zombie, what if I What if I want to store the method by which a zombie deals damage? So for example, I want to do this. The damage that the zombie deals is, for example, if the weapon, I will just type, if the weapon is hands, I want the damage to be, so return 5. And else, if, so will this work? No, of course not. I cannot like type a code inside the dictionary. Python won't access, won't understand. So it will give me an error. There's no way I can make it work. I cannot put a function inside. So for example, def damage, comma, return 5, for example. It's an error, invalid syntax, right? I cannot put a code, a method in a dictionary. So it has limitations, right? Yes, you can insert as a string like this. Yeah. But it is clunky, and the first problem still endures. We still have to, if I want to add another zombie, I have to redefine everything. And now I cannot like standardize, replicate. It is like, it's not so useful. There is a much better way. So in order to do this type of stuff, like storing methods, we use classes. So in a class, you can store anything. You can store variables, dictionaries, lists, everything, including functions, including code, including methods. So I'm going to do it. Let's come here. And now I will define my class zombie. No, this I will do later. So I will basically do this here. Instead of, this is self-explanatory. So basically you define the class, for example, here pager class, and it carries the method pager operation. And pager operation does exactly what we were doing before, which is take the value that you provide, the function, a times a plus a, and return it, right? So now you can define an instance of the class. So for example, instance equals pager class. So now instance, the variable instance, carries everything predefined in this class, pager class. And now I can access the function inside pager class, which is pager operation. And I do instance dot. So the dot, you are accessing stuff inside the instance of the class. And you provide a value, 5 here. And now print a. What is a going to be? 30, right? A will be 30. Let's play a little bit. Let's build this class. So I define the class. First I define the class, comma, right? Enter. Now I can put, for example, my function. And maybe I need an input, maybe not. But in this case, I need an input. Now I update the value of a, or just return. I can just do this. Return 8 times a plus a. Now I generate an instance of this class. So while we were doing zombie 1, zombie 2, zombie 3, zombie 4, defining everything again from scratch, now I can do instance 1 equals pager class, and I can do this many times. Instance 2 equals Pedro class, right? So now you start understanding how this is good for a game, because in a game you have plenty of zombies. Eventually one zombie will die. Eventually something that is not a zombie, like a human, will become a zombie. So you have to generate a new instance of a zombie. So instead of using the clunky dictionaries, use a class. Much simpler, right? So how do I access the function, the method inside Pedro class? I just call instance 1, for example, could be the instance 2, doesn't matter. And I call Pedro operation. I click it tab, so it because the spider software here was suggesting the autocomplete. Okay, and then I give an argument, and I don't know, I just printed this. Let's see. Let's see what happens. I need self here. I think that's it. Yes. Yeah, so you need this word self here, because the word self makes the method available for the entire class. That's something like that. I don't remember exactly the justification, but yes, you need this keyword self here, right? Then okay, printed 30. Nice. That's it. And I can create lots of instances of the class. And each instance is independent of each other. So for example, let's say I have more data in this class. Let's say I will do this and put some data here, for example, age, name, and track. Lots of information about me. So self age, the age of Pedro, so, and self name. I'm just defining, initializing the variables here. So self means that this variable can be accessed throughout the entire class. And my track. I'll give you an example. I'll address this like in more detail in a minute. And now each instance of Pedro, I can give, for example, the age is, for example, 25, name is Pedro, and track is bioengineering. But this other instance, I want to mess up. Pedro, 30 years old, name will be, I don't know, Mario, something like that. And track will be music, let's say. So this does not generate any conflict. I can runs normally. And now I can, for example, oh, what is the age of the second instance of the instance 2? So let's say, so let's change the name. This is Pedro. This is Mario. So what is the age of Mario? I just do Mario dot age. And now I'm accessing the age of Mario. So let's print this. Print Mario age. So in order to access this, it needs to be inside the init function, and it has to have the self before, right? Otherwise you cannot access it. Let's run this. Mario, so yeah, let's put another value, 31. There we go, 31. So Mario's age is 31 years old. All right. So I don't need to create a dictionary for Mario. and a dictionary for Pedro, and a dictionary for the pets, for example, James cats, and I don't know, dogs. For example, I only need one class for cats, one class for humans, one class for dogs, and I reuse them for other cats, for all cats I have. I reuse the human classes for all humans I have. I reuse all dogs class for all dogs I have in the simulation. James don't, so chickens. James has chickens, so I can use chicken classes. So imagine in a game, right? Imagine in a game, for example, you have, I don't know, lots of soldiers, lots of civilians, lots of zombies, vendors, everything, NPCs, everything you can specify as a single class. So it's like a set, you know, and inside this set you put all attributes, you put all methods. So for example, a zombie can infect other stuff while a man, a human, a normal human cannot. So in a zombie class, you can define a function called like infect and put stuff inside here. And when the human interacts with the zombie can use the function, the method infect that the human does not have. All right. So let's create a simple game. Let's delete everything here and create a simple game. Yeah, so that's it. So basically the advantages are store, organize, standardize, it's wrong, reutilize or reuse, replicate, everything. So class is the most powerful way to do things in a reusable standard way. All right. So let's open PyCharm. So things are almost, yeah. So I was doing it already. So I think I will show the result already because I think you guys followed. So in my little game, I have the agents. So this is a file, this is another file, and this is the advantage of using classes. I can define the classes in another file. So for example, the survivor, the class survivor is in the agents.py file, while all the weapons are in another file. So I have here hands and the pistol, right? They're in another file. So this is much more organized. So for example, let's say you are developing a game and you have now a new developer and you ask him, oh, there's a bug going on, or we have to nerf a certain weapon, we have to, I don't know, balance the game. So you tell him, oh, go to the weapons file and reduce the damage of the pistol. So this is extremely organized. If it was everything the same file, it's almost impossible to continue developing the game. All right. So here I have one file for weapons, one file for the agents, and the main file. So look how small the main file is. All right. And in the main file, I do stuff, for example, create a pistol instance. So pistol is from the WP file, which is weapons. I imported the weapons file as WP. So now I can access the class inside the weapons as WP dot pistol. I'm accessing this class here. Okay. And it requires an argument, ammo, the ammo of the pistol. So I insert the initial ammo of the pistol, let's say 12, something like that. All right. And the damage of the pistol is an attribute. Okay, so its data is stored in the class 50. And in the case of hands, so the hands don't need ammo. So I don't have anything. I don't have like ammo here. This will be done. But I have the damage of hands. So 1, let's say. Okay. Let's come back here. What else do I have? I have the survivor S1 and the survivor S2. And they start with life 100. And each one start with a certain weapon. So for example, I generated the pistol instance here, and I parse the pistol to the survivor. Now this survivor S1 has a pistol, while this other survivor here has only hands, bare hands, right? Let's go inside the agents file to see how the class survivor is being defined. So the survivor, it requires 2 arguments, life and weapon. So I say the amount of life it has, and the type of weapon it has. So I initialize everything. Now I have plenty of methods that the survivor has available. For example, the damage input and the damage output. So the damage taken is a method, and the damage dealt is another method. The damage dealt, of course, depends on the weapon damage. So this method will take the damage of the weapon, and look how interesting this is. When I parse, for example, the pistol to the survivor, and I do weapon.damage, this weapon is defined in this file, the weapons file. And this attribute, damage, is defined right here, the damage 50 or the damage 1. But although it's defined in another file, when I specified each weapon to each survivor, when I access the damage, it will import the damage from this file over here to the agent. Now the damage output knows what the damage will be depending on the weapon that the survivor has available. And of course, the survivor can die. All right. In the main file, so this can be very confusing, and I was confused in many occasions building this. Imagining like a real game, this is hell, right? So how do I deal damage in this game? I can, for example, ask what the damage. So first, careful. First, I ask what is the damage output from a survivor, and then I pass it as the damage input to the other survivor. All right, because this is basically the S1 survivor dealing damage to the S2 survivor. If it was the other way around, let's say S1 here and S2 here, the survivor S2 is dealing damage to the S1. So let's run it. See what happens. The survivor S2 has only hands, and the survivor S1 has a pistol. The pistol has damage 50, and they both start with 100 health. So in the first combat, the survivor S1 should deal 50 damage to the survivor S2. So I'm printing the life of survivor S2 here. S2 before the combat and S2 after the combat, right? Let's run it. Okay, so I do this 2 times. So in the first combat, this is basically shots fired. So started with 100 health, shots fired, 50 health. And now shots fired again, and the survivor dies, and it prints survivor dead. Why it prints survivor dead? Because in the agents, in the class survivor, when the life reaches 0, it calls another function, the function die. And the function die prints survivor dead. Okay? So imagine in, for example, a agent-based simulation where you have, in the case of bioengineering, you have a lot of cells, a lot of cell types. It's interesting. So in CompuCell, for example, there is a class for cell, and then you specify everything in that class, and you generate lots of cells with different specifications, but they are all the same class, the class cell. All right? So I will give a task for you, which is basically doing every time the agent shoots, it loses 1 ammo, and when the ammo reaches 0, it switches from pistol to hands. That's what I would like you to do. But first, or other than that, you also can build your own game. So yeah, this is the task I have to do. So you can take this piece of code here and implement ammo. So if the ammo reaches 0, switch to hands, and or you build your own game. And before we break the meeting, I want to talk about how it would be important, for example, for Danny and for Liam and Leo. So Alexander probably already understand the use of it because he will work with agent-based models. So Danny, probably when, let's say you are training a generation of AIs, of neural networks, you can specify one AI. So you can specify the AI as a class, and then you generate a bunch of different AIs and you give them challenges, and the ones that succeed, you take them and you generate a lot more AIs from these ones, implementing the generational algorithm for AI training. And you keep doing that. And how do you specify lots of the same agent using classes? All right. And in the case of Liam and Leo, so if you are going to develop, for example, the pages for CompuCell, the pages are defined as classes. They are defined as classes. So each page has attributes. For example, the buttons, the places, the fields to write stuff. So these are all methods from the class, inside the class, right? So this is just for you to see how widely you can use classes from development of softwares to, for example, AI training, games, simulations, etc. All right. So we have 5 minutes left. If you have any questions, please go ahead and ask me. If you want to give it a try, like defining your own class and start playing with it, I can stay a little bit more if you want help, if you want to play with it. Or if you want me to send the code for you, this project here, to give you a try, for example, in implementing the ammo stuff, which is not so simple, but yeah, it's not so challenging, but it's not simple either. So I can stay a little bit more here.
Yeah, I would love if you could just like send like code for like the sort of game you made, like just so, like when I'm like doing my own project, I can like reference it if I'm like need a reminder on any of like the behaviors of classes.
Perfect. All right.
Yeah, if you haven't used classes, they're very powerful, but they're not that intuitive when you're starting out. It is amazing what you can do with it. For example, a lot of the fancy neural networks like PyTorch are defined as classes. So you can load them into any Python object and use them. They'll work inside of CompuCell, for example, which is pretty neat. Doesn't tell you that they'll work fast, but that's a different question.
Yes, this small game project here has like almost everything you need about classes. Almost everything, I guarantee. This is like I actually had to learn new stuff to build this class. So I'm pretty sure you can handle almost any challenge you're facing in terms of programming with what you learned today. And I won't say you learned because that would be too arrogant from my part. But from what I'm going to send you, so in terms of referencing to this material, you will certainly be able to. So, like, I don't know.
Okay, and if you have any questions about anything else, I'm available as well. So
Yeah, that's it. Class material. I don't know, put all keywords here. Pedro, CC3. And maybe my PowerPoint, but I don't know. It's not like too important. Yeah, it's not important. Blocked for security reasons. I'm joking. I must be joking.
I don't really think I have like any questions at this point, but I do want to thank you for this, Pedro, because I think it helped me a lot with like understanding more like the syntax of Python related to this, but also like just how like classes fit into CompuCell 3D as a whole. Like this was very helpful.
Nice. That's the objective. I'll put in the drive for you to access because I won't be able to send by email, I think. So do we have a drive folder shared? James.
let me see. We created the Google Doc, but let me see if we have a drive as well. Hold on a sec. Good question.
So
Uh,
why we don't have a folder? I will share the link for you. So if someone can like just try to download it, it would be awesome to see if it works.
Yes, we do have a folder.
Oh,
We do have
nice,
a folder here. Let me share it with everybody again.
nice.
Let's see. So hold on a sec. Pedro, Danny, Alex. Uh, Okay, you should have the link coming in just a second. You got it?
Yeah.
And all of you should have it. The one problem with the Google Drive shared folder is you always have to bookmark it or say write down the link, because it's really easy to lose those. Finding shared folders is not trivial. So they're very convenient, but they're easy to lose. Well, thank you, Pedro, for doing this. That was great. Thank you to everybody for showing up on a Saturday evening when you might be off doing something like going to a bar or having fun, or so I do appreciate it.
Yes, thank you very much. This was very helpful.
Yeah, thank you again.
Thank you all for showing up.
Pedro,
Try
if you
to
could stay
download
on for
later.
just 1 second, that would be great.
Sorry, James?
I say if you want to stay on for just a second when everyone else is done, that's fine. If you have other things to talk about with them, that's fine too.
Okay. Okay, file is uploaded.
If anyone has trouble getting into that directory, let me know. I'll see what. Sometimes if I share it to a non-Gmail address, I have to give an extra permission to allow you in. So if it says you need permission, then just ask for it and I'll click the allow for it. All right.